Welcome back, everybody. Matt and Rachel here again. And we've got Isaac Plant here with us. We'll introduce him in just a second. But first of all, thanks to everybody who has stuck with us all day, especially through some technical challenges in the last panel, but I think there was some great content and really interesting discussions. So thanks, everybody. This is the final part of the day today before we close. We'll come back on after Isaac presents and share some closing thoughts maybe and logistics for the next couple days. But we're going to turn it right over to him. He's the only startup that's presenting and pitching this afternoon. So it'll just be a short presentation from him and he'll take questions and happy to answer anything about the work that he's doing. But Dr. Isaac Plant is the head of product development at Elm Innovations and holds a PhD in bioengineering from Harvard. So with that, Isaac, we'll let you take it over and share about Elm.
Yeah, thanks, Matt and Rachel. So I'm not a real doctor. I'm a PhD, but I work at Elm Innovations, and we're trying to reduce methane emissions from cattle. And so with that, I'll run through a presentation, and I'll show you some of the data that we're pretty excited about. And then if there'll be some time for questions afterwards. So any questions, we should have plenty of time for that. So without further ado, let me see if I can get this going. There we go. Okay, so I work for Elm Innovations, and what this stands for is Envisioning Low Methane. We're a nonprofit that's really serves as a funding aggregator and catalyst. We were started by a woman named Joan Salwin, who kind of had a distinguished career in consulting, and then at helped run a girls' school, and then decided and kind of became from a dairy family and I was at Stanford and had this opportunity to kind of think about solving a bigger problem. And when she was there, she kind of came upon the problem of enteric methane. So enteric methane, enteric means the gut, and methane is a gas. It is a very potent greenhouse gas. It's 25 more potent than CO2 on a 100-year timescale. And so enteric methane is the production in the stomach of cattle and other ruminants. So other ruminants include my favorite, the giraffe, as well as sheep, goats, but cattle really make up the most significant portion of this because there are 100 million about in the US, 1 point some billion in the world, and they just produce a ton of this methane. And this is not due to any specific feed, it's very much a fundamental portion of their biology. And this causes both the enteric methane to be the second largest contributor of methane in the US, but also just stepping back, as a greenhouse gas, the enteric methane makes up about 4% of all greenhouse gases in the world on a CO2 equivalence measure. And it also is so significant on a single cow level that a single California dairy cow, for example, is equivalent to about one 27 mile per gallon car over a year. So it's a really significant problem, and up to this point, there hasn't been a way to address it. And so this is what Elm stumbled upon, and what we saw, what Joan had dug out of the literature, is that a group in Australia had found a seaweed called Asparagopsis, and found that it contains a high concentration of an active ingredient called bromoform. And when you put it in a test tube that mimics enteric methane production, it reduced methane significantly in this Australian study. And so what Elm has really been trying to do is oh no, sorry for the typo, has been searching for an Achilles heel of this innovation. Because up until this point, there's no way to reduce enteric methane, and this seemed too good to be true. So what we've done is we've funded lab trials in 2017, a short-term dairy trial, which should be published shortly from 2018, and we're currently doing a live steers stockers trial, and also working towards future work. And I don't know if I mentioned this, Elm is a nonprofit, so this has been really to catalyze a market around this innovation, to verify it and then try and get it move the market towards acceptance. So to show you some data, which depending on you're either going to love this or your eyes are going to glaze over, we ran this in vitro trial with UC Davis. This is from a paper whose lead author is Brianna Roque. It's a PhD student in the animal sciences department at UC Davis. And what you can see on the left of your screen is essentially a test tube of a cow's stomach. And this is a test tube version of, you can count 6 cow stomachs. And what happened is that you kind of run this test tube of a cow's stomach, and you add in stuff that mimics feed, and you do it either with no seaweed or 5% of this seaweed called Asparagopsis. And what you see is over on the bottom axis, the x-axis of this figure, is how long you incubate these test tubes for, these artificial cow rumens for. And on the left-hand side, you see production of CH4, which is methane. And if you don't add seaweed, you see at the black line very high levels of, well, you see normal levels of methane production. And then if you look and you squint, you can see that there are gray bars for each black bar. And those are with 5% seaweed supplementation, and you've essentially knocked out all of the methane production. And this was great, but this was still a test tube trial. And so what we moved on to was a dairy trial. So this is a dairy cow. It's a Holstein. Its head is in a green feed machine. This is a machine that basically drops some alfalfa pellets, which are like cookies for the cows, and it measures their burps, where most of the methane comes out of, and tells you how much methane is being produced in the cow's stomach. And so we ran a 12 cow, 3-period, 21 weeks for each trial, or with each period. So 3 periods, 21 days. Sorry, back up. There are 21 days for each period. There are 3 periods, 12 cows. And we ran 3 different conditions. And so this is a bit of an overwhelming chart, but what you can see on top, the top figure, is supplementation with 3 different levels of Asparagopsis. And there's 0, 0.5, and 1%. And while this doesn't seem like a huge drop in methane, this is by far, for the amount of seaweed we supplemented, which is by active component quite low in this case, the 20% reduction and the 43% reduction in methane yield is the most by far exciting reduction that has been seen up until this point with methane reduction technologies. And what is also very promising is that with this inclusion rate of seaweed, you don't see, at least between 0 and 0.5%, a drop in milk yield, nor do you see a significant drop between 0 and 0.5% in dry matter intake, how much the cows eat. You do at 1%, but that's likely because of the seaweed being a little bit weaker than the seaweed we hope to use in the future. So that was our dairy trial. We have links to these, if anyone's interested, links to published research, I don't think we have anything unpublished on our website, but there's news coverage, mini documentaries, and other videos available on our website. And hopefully these will be being the dairy trial, which I've shown you some of the data, will be published. It's under review and should be published hopefully in the next few months. And we're hoping to, and we're ongoing with the steers trial, which is some exciting work as well. So it's been about 10 minutes. So I'm just going to finish up by thanking our funders. We, like I said, we're kind of we raise money and then distribute it. And we've been really lucky to have a lot of funding from the 11th Hour Project, which is the grant making arm of the Schmidt Family Foundation, Strauss Organic Creamery, which one lives in the California SF Bay Area. It's kind of some great milk. It's kind of like a really high-end milk here. And then we also have funding from the Silicon Valley Community Foundation, FAR, the Packard Foundation, Grantham Foundation, and Organic Valley have all helped out significantly. This work was performed at UC Davis, and we also have collaborations with Scripps Institute of Oceanography on the seaweed front. So with that, I think I'll stop sharing my screen. And if there are questions, I'd love to answer them.
Awesome. Isaac, thank you. Yeah, right now, I don't see any questions, but for a reminder for anybody who's live, the Ask a Question tab at the very bottom, if you have something for Isaac, feel free to throw it in there. I've got one to throw your way, Isaac, which is,
Sure.
if you can talk a little bit about this strain of algae and seaweed and how much of it is there? Is it currently cultivated? I'm thinking about, and this may be one step beyond the research, obviously, that you guys are doing, but curious if you guys have thought at all about the scalability and sourcing and all that from a feedstock perspective.
Yeah, so that's a really interesting question. We have thought a lot about it. Right now, the seaweed that we've used for these trials is wild harvested. So Asparagopsis is a red seaweed, which for people that really know their seaweeds means it has a complicated life cycle. And it's primarily found in tropical to subtropical regions. So if anyone's gone to Hawaii and eaten poke, it's actually a common flavoring there. But it's currently wild harvested, not currently cultivated, but we've been working with a number of partners to try and really jumpstart that supply, because you can just kind of off the top of your head say, well, we want to feed, say if we want to feed in the range of the numbers I showed, 0.1 to 0.5 or 1% feed supplementation, cows eat a lot. There are a lot of cows kind of, oh God, we're going to need a ton of seaweed. So I think Scripps has been doing some of that. I've been kind of looking at cultivating this in tanks, and they're doing some really exciting work. There's some really, we're really excited generally, not so much necessarily Asparagopsis, but the organization Green Wave is doing some really exciting work with seaweed generally in the US. So if anyone's just like, gosh, I want to learn about seaweed, I'd highly recommend Green Wave as a place to kind of look. But this is something that we kind of have ongoing work for, and are really is kind of one of the next major steps. Yeah.
Cool.
So.
Awesome. Yeah, we don't have any panels on this for the conference, but there's some really interesting work around the 3D farming space with both seaweed and other aquaculture opportunities, and Green Wave is certainly doing some really cool work.
Yeah.
So Isaac, there is one question that seems a little bit more technical. I'm sure you can see if you pull that up from the Ask a Question section. It comes from Jose. So what's the relevant chemical process by the seaweed? Is it absorption by dead seaweed or some sort of synthesis to a different carbon molecule?
I threw this out there really briefly in the beginning of the talk, but the seaweed, a lot of seaweeds produce an active component called bromoform. Most of them release it. This seaweed is very special in that it concentrates bromoform into a vesicle, if you will. And bromoform acts to binds in the cow's rumen. So this is the cows eat the seaweed, the bromoform ends up in the rumen. It binds to a cofactor that is necessary for methane production. And when bromoform binds to the cofactor, it sequesters it and prevents methane production. So it's fundamentally, it's the seaweed is producing a bioactive that is interfering with methane production.
Great. Awesome. Cool. So I guess if there are no more questions from anyone who's watching live, I think that's it. Oh, we can hit done answering the question. Cool. Yep. Great. So Isaac, unless you have anything else to add, thank you so much. But anybody who's interested in connecting with Isaac or anybody that has spoke today, feel free to kind of look through our list and do so and look up what Elm Innovations is doing. So we've ended our day on algae, methane, and cow burps, which is awesome.
Yeah.
So, Isaac, thanks for being here with us today. We hope you check in on the rest of the conference, and we're gonna let you go, say bye, but we'll have a couple of closing remarks as we send you off.
Yep. Thanks for having me. It's exciting stuff. The whole Ag Summit. It's cool to watch.
Awesome. We're happy to have you.
Yep.
All right. Thanks, Isaac. Okay. I think we're still live.
Yeah.
Great. Well, this is it, everybody. I was just writing it down, thinking about it. We went from robots to the state, our opening remarks, robots, the state of agriculture, seeds and flavor and chefs, to sustainability, food culture, and innovation and technology, all the way to cow burps and algae at the end. So
that's the best way to end it, I think.
Yeah. Any comments?
Not at all. This is great. Looking forward to the rest of the conference and see you all tomorrow.
Yeah, be sure to log in starting noon Eastern time. We will see you all tomorrow. Hopefully all the tech issues will be resolved, but thanks for bearing with us. And the summit continues. Have a great afternoon, everybody.
Bye.